Okay, having a look at question 17 from the 2021 Maths Methods Tech Active paper. So we've got a graphing question here. This one's interesting because there's only 4 marks allocated to it, and when you look at the marking scheme, there's only 1 mark allocated to finding out the functions. So the first thing you need to do is find out equations for those 2 graphs and then work with that. And there's only 1 mark actually allocated to that. So you don't want to spend too much time trying to work it out. So looking at the solid line that we've got here, we can see that we have what looks like a sine curve. We can see that it has been moved up by 9, and it goes up to 11, down to 7, so the amplitude's 2. So if we're looking at a basic one, we've got like a sine x, we know our amplitude's 2, and we've got a plus 9 on the end. What we need to work out here, it doesn't look like there's a phase shift, we need the period. So we have been given this value here of 12, so we know the period is 12, so using our 2 pi on b equals 12, 12b is 2 pi, so then b must be 2 pi on 12, which is pi on 6, so we get pi on 6t there, where t is our time. Another option, if you're familiar with your calculators, is to go and use your sine regression. So not sure if it ends up being that much easier. You're putting in your values, you need to go over to calc, look for the sine reg. There's one iteration, as in 1 cycle, and you need to tell it what the period is. And then when it comes out, you've got your amplitude, you've got your vertical shift there. It gives you this b value in decimals, so obviously you would need to convert that into your pi, which you can do obviously, but it's just an extra step there. That may be helpful, may not be helpful. We don't have a cos one on our Texas Instruments, so this one is a cos. When it would do that, it would give you a phase shift for a sine, so it would make it a little bit more difficult. Looking at the dotted line one then, we've got our cos, so we know we've got the same period, so we can make that as a pi on 6t there. It's been shifted up 11, so we've got a plus 11 on the end, and its amplitude goes from your 11 up to 14.5 and 11 down to 7.5, so it is a 3.5 amplitude that goes there. That's the 2 equations. You only get 1 mark for those. Then if you're looking at the total population, you're obviously adding those 2 numbers together, so you're just combining those 2. You've got your 9 plus 11, so you've got your plus 20, and then you've just got your 2 sine pi on 6t plus the 3.5 cos pi on 6t. Once you've got that, you're then asking to investigate the reasonableness of Jane's claim, and she's claiming that there were periods of time over the 2 years when the population of foxes and rabbits on the island exceeded 25,000. So that's when we're then going to grab our calculator, remembering to put it into radian mode here because we are using pi. We can put our equation in, so we have the 2 sine and then our pi on 6x, then we've got plus the 3.5 cos our pi on 6x, and then we've got the plus 20 on the end. So we can then graph that. I'm obviously going to have to change my window because I think my window has a very small x value there. I can't remember what I had in it last. I'm waiting for the calculator to think a bit on this one. And I'll go to my window. I've gone from the X max to 1,000, which is why I can't see it. We're looking over 2 years, and ours is in months here, so if I put between 0 and 24, that should be plenty. I also know it's going between 0 and 15 on my graph here, but I'm looking for whether it goes over 25,000 when it's the total, so I want to make sure I've got enough space there. So I'm going to put go between 0 and 30, and then I'll be able to see, hopefully, that graph there and what I'm looking at. So looking at the graph, I then want to see, does it go over 25,000? If I put a y equals 25 on, then I can see whether that clearly that the graph does not go over 25,000 there. So evaluating that claim, I would then say it is not reasonable because looking at the graph, it does not go above 25,000 on the graph there in those 2 years that we are looking at. Looking at the graph, I can't see that it exceeds there. So that's our evaluation.